Hello everyone, good evening. Am I audible?
Yes, sir.
Okay. So in the last class, we were talking about limits. Actually, we were talking about continuity. So, but before continuity, we know that we have to understand limits. And we have talked about some things. I would. I also told you to read NCRT from page 147 to 158. If you have any doubt regarding that, I mean, if you have read these pages and if you have any doubt, please feel free to ask me. Okay, you can just raise your hand and I'll come back to you. And by that time, I will just revise the concept. So we know how to find out limits. There are some formulae to solve limits, right? And we have these 6 formulae to use limits. We will understand while solving the questions how to use these formulae, right? And we know that if we are saying that limit exists for a function, it means that left hand limit and right hand limit at that point should be equal. Okay, so we don't know about that, but yeah, we have talked about how to find out LHL and RHL. What do we mean by left hand limit and right hand limit? So left hand limit at any point means that negative. So if I'm saying that LHL at x is equals to 2, it means that 2 negative, and RHL at x is equals to 2 means 2 positive. Now what does 2 negative means? 2 minus h, right? So we talked about these first 3 steps. First step would be to write limit extends to whatever you are finding. If you're finding out, let's take a general point A. So if you're finding out LHL at x is equals to A, it means that x tends to A negative, right? Limit extends to A negative fx, right? And A negative money A minus h. And similarly, if you're finding out RHL, then you will write limit extends to A positive. I'm talking about x is equals to a general point, right? So you will write x tends to limit x tends to a positive fx, and a positive means a plus h, right? And then you will, in the next step, you will write this. Okay, so you don't need to write this every time, but because we were solving the first question, that is why I wrote this. Otherwise, we don't need to write this step every time. You can just jump from this to this. Okay. Or maybe you can also use one more step here. Instead of using this, what you can do is, I'll tell you. Okay.
Yes, sir.
Yeah. So
Exist
okay,
when,
yeah. Sorry.
when does limit exist?
Yeah, limit. Now we will also talk about when limit exists and when we don't have limit. I mean, when does limit exist or not? So if after putting the values directly, or maybe you can also use the term if after putting the limits, if your answer is plus minus infinity, then I told you to recheck once whether your calculations are correct or not. If your calculations are correct, it means that the limit is plus minus infinity. Basically, the limit does not exist, right? And if your answer is some indeterminate form, basically 0 by 0, okay, what you can generally observe are 0 by 0, infinity by infinity. These two will be the most basic forms which you will encounter. So if you got an answer like this, 0 by 0 or infinity by infinity, then you have to solve that limit using some formula. Okay. But if the answer is plus minus infinity, I would suggest you to first recheck. And if still the answer is plus minus infinity, then it means that the limit does not exist. Okay, now let's come to the another part. One more important step which I would like to tell you. First of all, this is what will be our concept for continuity. How do we check whether a function is continuous at some point or not? So to check the continuity, of y is equals to fx. So let's say we have a function y is equals to fx. And we want to check whether this function is continuous or not at x is equals to a, some general point, right? So how do we check that? There must be two conditions. First, fx, or whatever your function is, fx must be defined at x is equals to a. We should have some value for the function at this point. That is, fa, we can write it like this. Fa, we are just replacing x with a. So fa must exist. Exist meaning there must be a finite value for this, right? Maybe 0, 2, 100, minus root 2, whatever. There must be a finite value, right? And second point is, limit x tends to a, fx must exist. Now, the second point is important. First point is pretty simple, pretty basic. You can always check out whether fa exists or not. But the second point, limit x tends to a, fx must exist. Now, what does this mean? It means that limit x tends to a negative, fx, what do we call it? LHL, right? LHL at x is equals to a should be equal to limit x tends to a positive fx. So what I have written is, I have written that limit x tends to a, fx must exist. That is, the limit at x is equals to a for the function fx must exist. Now, what does that mean? It means that your LHL and RHL both should exist. That is, they must be a finite value and they both should be same. If your LHL, that is left hand limit, and RHL, that is right hand limit, for some function at some given point, in this case x is equals to a, are equal, then you say that limit x tends to a, fx is existing. And what is the value of that value? I mean, what is the value of limit x tends to a, fx? Whatever will be the value for both of these, that will be the value of limit x tends to a, fx, right? So first point is, if you want to check continuity of a function at some point x is equals to a, then first point is, for that point, the value of that function must exist. So if I'm checking for x is equals to a, fa must exist. First point. Second point, limit x tends to a, fx must exist. That is, LHL at x is equals to a and RHL at x is equals to a, both must be equal. And if the function is continuous, they all three must be equal. So if you are saying that the limit, if you're saying that the given function is continuous, it means, and at some point x is equals to a, it means that value of the function at x is equals to a, which can be called as fa. Fa should be equal to limit x tends to a negative fx should be equal to limit x tends to a positive fx. So if I'm checking the continuity of a function at x is equals to a, then I can simply say, I mean, what both of these points are suggesting is this, that if you are saying that if you are checking at x is equals to a for the function y is equals to fx, whether this is continuous or not, so you will check these three things. Limit x tends to a negative fx, LHL at x is equals to a, then the value of the function at x is equals to a, and RHL of the function at x is equals to a must be equal. If these three things are equal, then I'll say the function is continuous at this point. The point is x is equals to a. Now we will check with some questions. This is the concept of continuity. We will check these three things. We will try to find out whether these three are equal or not. If even one of them is different, then I will say that the function is discontinuous, right? And while solving these questions, we will also learn how we can solve limits, right? Shallow, then let's come to some examples first. Okay. Let's solve this one. Discuss the continuity. Discuss the continuity of y is equals to mod x, or they can also write fx is equals to mod x. You know, both are same things. Discuss the continuity of y is equals to mod x at x is equals to 1. So continuity is an easy topic, I would say. First of all, this will be scoring, but you just need to be with me for this class. Just understand what I'm saying, and wherever there is any doubt, please feel free to ask me. Okay. So there are 2-3 types of questions. Okay. First is the most simpler one. These are the simplest actually. So in these questions, you will be given a function, and you will also be provided a point, and then you will need to check whether that function is continuous at that point or not. Right. So what I would do is I would find out these 3 things and would check whether the function, all the 3 values are equal or not. Right. So first of all, we have fx is equals to mod x. Right. For fx is equals to mod x to be continuous, I want to check its continuity at x is equals to 1. Right. So what I can say is, if this is continuous at x is equals to 1, that I need to find 3 things. Right. Now, first thing is find first. What is the first thing? First, find limit x tends to 1 negative fx, which is the LHL. Right. Then second, I will find f1. Right. I'm checking for x is equals to 1. I'm just putting these things in this formula which I have written. This is the concept, right? So, and I know the value of a is 1 in this case, because I want to check the continuity at x is equals to 1. So instead of a, we are using 1. Right. Okay, so I'm checking the LHL at 1, which I have written firstly. Then secondly, I want to check the value of this function at 1, which is f1 basically. And third, and lastly, the value of the function at x is equals to 1 plus, sorry, the RHL at 1. So let's first calculate LHL at 1. I can, in the next step, what I can do is I can write it as limit h tends to positive. Why? Because I know 1 negative mane 1 minus h. So what I'm doing is, instead of x, I will replace it with 1 minus h and limit h tends to 0. Nothing fancy, just the basic steps. Instead of x, I am using 1 negative. Now I know 1 negative is not something. 1 negative means 1 minus h. So I am writing limit h tends to 0, f of 1 minus h. Right. Now I will replace limit h tends to 0. I know what is fx. Fx is mod x. So instead of mod x, I can write mod of 1 minus h, because fx is mod x. This is fx. Right. Now h is lagbhag 0. H is approximately equal to 0. Use the value. Put h is equals to 0. This is mod 1. Right. Mod 1 is what? 1. Again, f1. I want to find out f1. What is f1? Just replace x with 1 in this function. So it will be mod 1. Mod 1 is again 1. I'm also writing the name of these things first equation, second equation, then I'm now calculating third equation. So it is limit x tends to 1 positive. Now I know what is 1 positive. 1 positive means 1 plus h. So instead of x, I'm writing 1 positive, which is 1 plus h. Now I will replace this in this function. I know the function is fx is equals to mod x. So if I'm replacing x with 1 plus h, I will also replace x with 1 plus h in the right hand side. So this becomes limit h tends to 0 mod of 1 plus h, right? Now you put h is equals to 0, you get mod of 1, which is also 1. Now you can check that first, second, and third, all of these equations are giving you the same answer. From first, second, and third, limit x tends to 1 negative fx is equals to f1 is equals to limit x tends to 1 positive fx. Right? And all of these values are equal to 1, which suggests that the given function is continuous at x is equals to 1. Now, before we go further, I would also like to talk about the graph of this mod x. I've already, I don't know in which class, but we have drawn this graph. And at that time, I have told you what is the graph of mod x. So you can also check this from mod x, graph of mod x. The graph of mod x is like this in the shape of V. Now you can check this graph is continuous at all points, right? So if you check it for one, if you check it at x is equals to 1, x is equals to 0, x is equals to 2, x is equals to 10, at whatever point you want it, this graph is continuous at all points, at all real numbers. That is why these all three limits came. All three of these things came same, right? So it implies that y is equals to mod x or fx is equals to mod x is continuous at x is equals to 1. These are the most simplest ones, जिसमें we don't have to do much. We just have to calculate all these three things. The function will be given, the point will be given at which we have to check the continuity, and we can easily solve this. Anji, any doubt?
No, sir.
Okay, if not, then please solve this one. Everyone have to solve this. These are the most easiest ones, तो आपको ये इतना ज़्यादा देखने को नहीं मिलेंगे. These questions will not be frequent. They are very easy. But just for the sake of that, whether you know this or not, I would like you to check this one. You all have 2 minutes, do it quickly. We are not replacing x with h tharif. We are replacing x with either a negative or a positive. A negative माने a minus h and a positive माने a plus h. Where we are saying that पहले हमने बोला x टेंड्स टू a नेगेटिव, बाद में हम बोल रहे हैं लिमिट h टेंड्स टू 0, और x को h से रिप्लेस नहीं कर रहे, या तो x को a नेगेटिव से रिप्लेस कर रहे हैं फॉर एग्जांपल, या तो x को 1 नेगेटिव से रिप्लेस किया मैंने पिछले वाले क्वेश्चन में, या फिर x को 1 पॉजिटिव से रिप्लेस किया। अब 1 नेगेटिव का मतलब ये है 1 माइनस h। जैसे फॉर एग्जांपल यहाँ पे देख ले, ये वाला देख, यहाँ पे मैंने x को 1 पॉजिटिव से रिप्लेस किया है, h से नहीं। नो, why would I replace x with h? I would replace x with या तो a नेगेटिव, a आपको दिया होगा हर क्वेश्चन में, या फिर a पॉजिटिव। फॉर एग्जांपल इन दिस केस a की जगह 1 था, क्योंकि मुझे 1 पे कंटिन्यूटी चेक करनी थी, तो आई एम रिप्लेसिंग x विद 1 पॉजिटिव। अब 1 पॉजिटिव का मतलब क्या है ये समझ, 1 पॉजिटिव का मतलब है 1 प्लस h, 1 से थोड़ा सा बड़ा, है ना। तो अगली लाइन में मैंने x की जगह 1 प्लस रखा, विच इज बेसिकली 1 प्लस h, और इसमें अब क्योंकि x नहीं है, तो अब मेरे को लिमिट मेरी बदल जाएगी। अब लिमिट पहले थी x टेंड्स टू 1 पॉजिटिव, बट वो तो मैंने यूज कर ली, तो उसकी जगह मैं ये कह रहा हूं कि ये h जो है ना, h ये बहुत छोटा सा है, तो लिमिट h टेंड्स टू 0 हो गया। तो हर बार यही होगा नेक्स्ट स्टेप में, a की वैल्यू बदलती रहेगी, यहाँ पे a कुछ भी हो सकता है, पर पहली बार लिमिट होगी x टेंड्स टू a पॉजिटिव या a नेगेटिव, डिपेंडिंग ऑन टू RHL कैलकुलेट कर रहे हैं या LHL कैलकुलेट कर रहे हैं, और नेक्स्ट स्टेप में जाके लिमिट h टेंड्स टू 0 हो जाएगा, और आप x की जगह रख दोगे a प्लस या a माइनस। a प्लस का मतलब a प्लस h, या a माइनस का मतलब a माइनस h। समझ आया क्या बोल रहा हूं?
Yes.
ओके, जैसे यहाँ पे देख x की वैल्यू 3 है, तो मुझे 3 पे चेक करना है कि ये फंक्शन कंटिन्यूअस है या नहीं है। तो इस बार जब मैं LHL निकाल रहा हूँ तो मैं बोलूंगा x टेंड्स टू 3 नेगेटिव, RHL निकाल रहा हूँ तो आई विल से x टेंड्स टू 3 पॉजिटिव, एंड नेक्स्ट स्टेप में आई वुड रिप्लेस x विद 3 प्लस h, और लिमिट में मैं रिप्लेस कर दूंगा h टेंड्स टू 0। Solve this, you have 1 minute guys, fast, you can give me your answers on chat box. Austin correct, good. Ji, only Austin, this is correct. Oh, sorry. Only Austin has solved it. Why? This is the most easiest one यार, इसमें तो कुछ करने का ही नहीं है, सीधा सीधा LHL RHL निकालो, वैल्यू निकालो फंक्शन की 3 पे, तीनों को चेक करो, और इसमें तो मेरे को लिमिट्स भी मतलब एक्चुअली सॉल्व करने के लिए कुछ भी नहीं करना, सीधा सीधा बस लिमिट्स उठा के पुट करनी है। करेक्ट है शाविस। Abhi, I'll also tell you the shortcuts for all of these, but first go conventionally. First approach should be to go conventional, so that if there is a mix up or there is a different thing in exam, so we don't suffer. I'll also tell you shortcuts ke kaise hum inko jaldi solve kar sakte hain, aur these are very easy questions. You won't get this question in exam, obviously. But if you won't solve this, you won't get the next questions. ठीक है यार, कुछ नहीं करने का है, सीधा सीधा उठा के तीन ही चीजें चेक करनी है. पहले मैं क्या निकालूंगा? LHL. LHL at x is equals to 3. So what is that? Limit x tends to 3 negative fx. Right? So there is a shortcut for this. एक तो ये तरीका है कि I can go like this. Right? This is one way. And then I go like this. Limit h tends to 0. X की जगह I will replace with 3 minus h. Okay. So I will write 2 into 3 minus h whole square. Right? It was 2x square. So instead of 2x square, now it is 2 into 3 minus h whole square. Minus 1. Right? And then I will put h is equals to 0. So ये बन जाएगा 3 square 9. 9 into 2 18. 18 minus 1 17. So this is one way. But एक दूसरा तरीका ये है कि आप LHL while calculating LHL and RHL, just put the value directly. What is the value directly? 3 negative है ना? It is 3 negative right now. So you put 3 directly. 3 negative माने 3 minus h, and 3 minus h माने 3, because anyway you are putting that h as 0, right? So you put that value directly and see if you are getting a finite answer or not. So if I put 3 directly here, I get a finite answer, right? As soon as I get a finite answer, मेरे को पता है यार, now I know that this LHL is 17. RHL will also be 17. You can check this. Okay, come. RHL at x is equals to 3. The right way to solve this, how to write this, will be the way like we are using. But how to check it yourself? So उसके लिए तो आप directly इसको you can put x is equals to 3 in this. If you get a finite answer, then LHL, RHL and value of the function will be finite. All will be finite. But if you are getting an indeterminate form, then there will be a problem. Then you will have to solve. Hey. Okay, so RHL at x is equals to 3. RHL at x is equals to 3 would be limit x tends to 3 positive, right? Fx. Now, to write this in exam, I will have to go through the similar steps. Limit h tends to 0, f of 3 plus h, right? And then I'll solve this. But in my head, I can solve this within one step. I know the answer will be 17 if you put h equals to 0. वो मैं यहीं से ही देख सकता हूँ सिर्फ. I can only check it from here. I'll put directly at x is equals to 3. If the answer is finite, I know this is continuous, 100% continuous. We don't even need to solve all of this. That is why we won't get this question. And the third thing would be the value at 3. So F3. F3 would be 2 into 3 square minus 1, which would again be 17. So from first, second, and third, you can say that fx is continuous at x is equals to 3. Right? So these will be the most easiest questions. Now, after this, I would like to tell you one more rule. See, if the function is polynomial, then it is always continuous. You don't need to even check. This is a theorem for you. So you can check in this example, we have used fx as 2x square minus 1, which is a quadratic polynomial, right? So if fx is a polynomial, then it will be continuous over all the real numbers. If y is equals to fx is a polynomial, oh my God, what is happening? So if y is equals to fx is a polynomial, it means fx is continuous fx is continuous at all x, or you can say that x belongs to real numbers. So you can also use this result directly, that if fx is a polynomial, it is continuous everywhere. You don't need to even check. Polynomials are continuous. Polynomials do not have any point of discontinuity. That is why the graph of linear polynomial is a straight line. And that straight line doesn't break anywhere, if you remember that. I don't know whether you remember or not, but linear polynomials have, linear equations have the graph straight line. Can you tell me what is the graph of quadratic polynomial? What do you call it?
Parabola.
Parabola, correct. And parabolas are also continuous, if you remember this. So you know the graph of two polynomials. One is linear polynomial, which you have drawn in class 10th, and then in class 11th you have studied parabola, both of which are the graph of two polynomials. Linear polynomials have straight line and quadratic polynomials have parabola, both of which are continuous everywhere. So you can easily remember this result, that if fx is a polynomial function, then it will be continuous at x is equals to all real numbers. Okay. Yeah. So one result is this. Also, we have, we do know the continuity and discontinuity of the most used functions. Like we study all these kind of functions. अभी तो हमारे syllabus में नहीं रहा ये सब. But last year तक तो मैं भी ये सब पढ़ाता था कि आपको I teach all kind of functions. In class 11th तो पढ़ाते ही हूँ मैं अभी भी. But in class 12th I don't teach them because there is a lot to look forward to other than functions also. So that is why, but we know about all the, continuity and discontinuity of all the most used functions. And most used functions mane polynomials, trigonometric functions, all the 6 trigonometric functions, and then this modulus function, then greatest integer function, then exponential function, logarithmic function. With these 6-7 kind of functions, so I teach to every CBSE board student also, and we do know about these continuity and discontinuity. So they won't ask you these simple questions, although there's an important question here which we would solve in the end of the class, at the end of the class, which is the discontinuity and discontinuity for greatest integer function. We'll discuss that little later. Okay. So the first kind of questions was just to teach you how the questions will be solved. They won't be asked in the exams. Okay. Now the second type of questions, which will also not be asked in the exam, but in this, a curious point is that you will not be given that point at which you have to check the continuity. For example, I would write a question here. Also, sorry. Before moving to the question, I'll also write one more thing. Chalo, I'll write this after this question. First, let's solve this question. So the question is, examine the continuity of fx is equals to 1 upon x minus 3. 1 upon x minus 3. And they won't tell you what is the point at which you have to check the continuity. This is the interesting thing, right? So first kind of questions where they will just write here x is not equals to 3. Do you understand what does this mean? Can someone tell me why did we write x is not equal to 3?
Or else it would be not defined.
Sorry, come again.
Or else it would be not defined. X would be 3, then the denominator would be 0.
Yeah, correct. Right. So if, I mean, this is not in the domain, right? If x is equals to 3, then your denominator would be 0 and the function will not be defined at that point, right? So there'll be some questions in which you would be either given these kind of things where, I mean, you will be given the function and you will be asked to check for the continuity, right? Now, there can be multiple functions here. I would like to write 2-3 functions. So first function is fx is equals to 1 upon x minus 3. So how should I check? सबसे पहले तो मेरे को यही पता होना चाहिए ना, where should I check the continuity at? You have not given me any point. What do you want to understand by the continuity? I mean, give me some point, no? Then I'll tell you whether the function is continuous or not at that point, right? So you have to identify yourself for which point he's talking about, right? So, okay. So first kind of question is this, then second kind of question is this, mod of x minus 5. Or maybe this 2x minus 3, right? Okay, your NCERT has 4 questions. Yeah, let's take this one also. And the D part is, because I am only solving A and D. I mean, I'll also only talk about A and D. B and C are pretty straightforward. We don't need to even solve them. Yeah. So the second type of questions will be, also obviously they also won't be asked, or if they are asked, they won't contain more than 1 or 2 marks, because the concept is not this, that whether you can check the continuity or not. The concept is whether you understand at which point you need to check the continuity, right? Okay, so let's talk about B and C first, then we will come to A and D. So for B, this is a modulus function, right? And modulus function is always continuous. Yeah, Shaviz, you want to ask something?
I was outside for 5 minutes. Can you just explain this?
Which one?
Now only one point here.
Sorry, Shaviz, I didn't get you what you're saying.
Polynomial, sir. Polynomial function.
अच्छा, polynomials, okay. So polynomials are continuous everywhere. Okay. तो यार एक सबसे पहले ना शाविज continuity discontinuity क्यों आ रही है? Discontinuity will only arise because LHL and RHL and value of the function at that point is not equal. That is why there is a discontinuity, right? Now let's come to the polynomial. कैसे होते हैं polynomial? What are the general shape of polynomials? Okay. So I'm writing here a polynomial. So generally, generally what? Polynomials are these kind of functions. Understand what are the polynomials? I mean, पढ़ाया तो 9th class से गया, I don't know, but I am very sure कि you don't know about polynomials. तो polynomials कुछ इस तरीके के functions होते हैं, कुछ इस तरीके के expressions हैं. These are algebraic expressions in which these a0, a1, a2, a3, similarly up to. Just give me a minute. I'm writing the general expression for a polynomial. So these are the general, this is the general expression for a polynomial. Every polynomial can be defined in this expression. Okay. For example, this is a polynomial C. Fx is equals to 2x minus 3. So if I compare both of them, right? So the value of n would be 1. Value of a0 would be 2. Compare them. Value of n, which is the highest power of x in that polynomial. So highest power of x in this case is 1. And the coefficient for that power is a0, which is 2 in this case, right? And then a1 will be minus 3. So I can compare any polynomial with this equation. This is a general equation of the polynomial, which says a0, a1, a2, an minus 1, an. All of these are the real coefficients. Guys, just give me a minute here. There are kids around. Yeah. So this a0, a1, a2 up to an, these are all coefficients, basically constants, and these are the power of x associated. The highest power of x will be called the degree of the polynomial. So in this case, this polynomial has n degree, right? And similarly, you can define any polynomial. So polynomials will be this kind of expression. Okay. Now, if you check LHL, RHL, and value of the function at some given point. So let's say I'm checking this. I'm taking a general point, okay, which is, let's say, कोई भी general point ले रहा हूं मैं, and I am expressing that as x tends to k. K can take any real number. K can be 0, K can be 1, K can be 2, K can be 3. अब मेरे को तो यार हर point पे दिखाना है ना continuous है, तो I can't take a single point. That is why I'm using an arbitrary constant. Arbitrary constant माने it can also take any value, but this is a constant. We are saying this. So if I'm saying x tends to k, it means that k is an arbitrary constant. So I am saying basically x can take any real value. Either you can use 10, 9, 0, root 2, whatever you want to use. Okay. So if I'm taking limit x tends to k negative, so k negative माने होगा k minus h. And I can simply replace h with 0. Right? Now you put any point, k negative, k positive, and k. All of three would be same. Why? Because there would be no indeterminate form in this case. ना ही तो देख indeterminate form आएगी कभी भी, क्योंकि denominator में कुछ है ही नहीं. And neither there will be an answer like infinity, plus minus infinity. Why? भाई मतलब आप कोई भी algebraic expression लो, if you take any algebraic expression and you take any real number in that, so the answer would be a real number only. If you put 10, answer would be 17 in this case. I'm talking about this. You take any polynomial, तो क्या होगा, मतलब पावर्स ही तो इंक्लूड हो सकती है ना बस. तो आप कोई भी पावर लोगे तो आंसर तो रियल नंबर ही रहेगा, बड़ा हो सकता है, चलो हाँ ओके. यू आर सेइंग कि जी नहीं, हमारे पास तो fx ये है, x की पावर 7 plus x to the power 6 minus x to the power 5 plus 4x minus 5. Let's say this is the expression which we want to use. Okay. Now I want to check whether this function is continuous at x is equals to 10 or not. Okay, find out LHL at 10. तो क्या होगा? 10 negative, 10 minus h. You would put 10 minus h in place of x, which will give you what? Nothing different. This will be a big answer. Okay, but that is perfectly okay. Answer can be big or small, but answer will be finite. Definitely finite. Whatever that value is, right? So all the polynomials will behave like this. नहीं तो वो कभी plus minus infinity answer देंगे. They won't produce plus minus infinity, and neither they will produce indeterminate form. और जब ऐसा कभी होगा ही नहीं, तो LHL, RHL and value of the function at given point will always be equal for a polynomial. समझ आइए बात शाविज?
Yes, sir.
मतलब प्रॉब्लम तब है ना, देख, बिफोर अंडरस्टैंडिंग के why this is continuous, just understand why a function is discontinuous. What are the factors that make a function discontinuous? There are only three factors. Okay, there are only three factors. First factor is if the value either LHL or RHL, I'm talking about all these three values. I mean, there are three values that will come out in the end. One will be LHL, one will be RHL, and one would be the value of the function at the given point at which we are checking the continuity, right? So either आपकी LHL उस point पे plus minus infinity दे सकता है या indeterminate form दे सकता है, या फिर आपका similarly RHL उस point पे plus minus infinity और indeterminate form दे सकता है, या फिर उस function की value उस point पे plus minus infinity और indeterminate form आ सकती है, right? यही तीन reasons हैं जिसकी वजह से there is a function which is discontinuous. The discontinuity of a function will be only because of three reasons. Either any of the three answer is coming out plus infinity, or any of the answer is coming out minus infinity, or any of the answer is coming out indeterminate form. If there is nothing like that, तो कभी discontinuity आएगी ही नहीं यार. That is why polynomials के केस में कभी discontinuity नहीं आती, क्योंकि ना ही तो वो plus infinity produce करते, ना ही वो minus infinity produce करते, और ना ही वो कभी भी आपका indeterminate form produce करेंगे. और अगर तो इसका proof भी दिया हुआ है by the way बुक में, तो you can also check that proof, but वो भी ऐसे ही दिया होगा I guess. Limit x tends to c negative, fx would be same as limit x tends to c positive, fx would be equal to fc.
Sir.
Yeah.
Sir, so like 1 by x minus 3 is not a polynomial.
No, definitely not. We are coming to that point. मैं पहले उसको बोलने वाला था, पहले ये बात भी, बट फिर मैंने सोचा कि पहले क्वेश्चन कर लेते हैं, उसके बाद बताता हूँ. ये पॉलिनोमियल फंक्शन नहीं है शाविज, ये एक रैशनल फंक्शन है. रैशनल फंक्शन इज जस्ट सिमिलर टू रैशनल नंबर्स. तो रैशनल नंबर्स आर p by q form, right? Okay, so let's come to this. You can understand this very easily. Integers होते हैं, right? In what are integers? 1, 2, 3, -1, -2, 0, right? These are all integers. Then we have rational numbers. What are rational numbers? Integer by integer, right? एक इंटीजर ऊपर, एक इंटीजर नीचे, और नीचे वाला इंटीजर 0 नहीं होना चाहिए. You cannot take 0. So these are rational numbers. Similarly, you can, I mean, the role of integers in numbers is similar to the role of polynomials in algebraic equations. Let that just sink in. The role of integers in numbers is similar to the role of polynomials in algebraic equations. तो जैसे आपके integers, the same are your polynomials, right? And then if you take polynomial upon polynomial, then that is a rational function, just similar to rational numbers. So if I'm writing 1 upon x minus 3, then I can say, okay, now you will say कि 1 तो integer है, but 1 is also a polynomial, right? Constant polynomial. I mean, all the integers are constant polynomials only, if you figure that out. Do you understand that? What did I just say? All the constants or all the integers are just constant polynomials. What are constant polynomials? Constant polynomials in which the degree is 0. Linear polynomial is in which the degree is 1. Like this is linear polynomial because the degree is 1. If the degree is 2, quadratic polynomial. Similarly, what are constant polynomials? Integers or maybe numbers. Not just integers, but numbers also. 0.7. हाँ जी, constant polynomial है, कोई problem नहीं है. So this is also polynomial upon polynomial form. So when you have a polynomial by polynomial form, this is called as rational function, rational algebraic function. And by the way, all the rational algebraic functions are also continuous. All the rational algebraic functions are also continuous, barring the point at which the denominator is 0. So if I'm talking about fx is equals to 1 upon x minus 3, this will be continuous barring x is equals to 3. Now why x is equals to 3 is the point of discontinuity? Because at x is equals to 3, the function is not defined. There is no value for f3. So आप LHL RHL तो निकाल लोगे. You can find out LHL and RHL. But what will be about f3? You will never be able to find f3 because f3 does not exist in this case. That is why the function is discontinuous at x is equals to 3, but continuous everywhere else. So that is what I actually wanted to write here before starting the question, that a rational function is always continuous, barring where the denominator is 0. But I will write that in some time. We'll come to that point also. Okay. Yeah. So let's talk about these two functions first, B and C part. So B part is modulus function, which is always continuous. Don't even think about it. Modulus function is always continuous. Yeah, jab tak there is nothing in denominator, don't even think. I mean, if there is a polynomial function, if there is a modulus function, they will always be continuous. I'm also writing this. A modulus function is also always continuous. If the modulus is in numerator only. If there is nothing in denominator, then don't worry. As long as the function is polynomial, as long as the function is modulus, and there is nothing in denominator, good to go. Always good to go. The function is continuous. So if y is equals to fx is a modulus function, it means if y is equals to fx is a modulus function, then also fx is continuous. But because you are just starting out on continuity, that is why we wanted you to solve these questions for yourself. But now you can remember the results because you have already checked it. So fx is continuous at x belongs to R. हमेशा continuous होगा modulus function. So B is a modulus function, C is a polynomial, they are continuous भैया. उसमें तो कुछ सोचने का ही नहीं. Modulus है.
It is in numerator, right?
Sorry, you can. I mean,
If it is in numerator, so it will be continuous.
हाँ बिल्कुल एकदम. अब ये प्रॉब्लम हो जाती है अगर हाँ आप ऐसे बोल रहे हो 1 upon mod x minus 5, then that is surely a problem because there is something in denominator and that denominator will make it discontinuous. क्योंकि denominator कभी 0 नहीं हो सकता and there will be a point where denominator is 0. What is that? X is equals to 5. So that condition says that your function is not defined at x is equals to 5. And that is why it will be discontinuous at x is equals to 5. Right. Now let's come to A and D. So first of all, I have already explained what kind of functions A and D are. A and D are rational functions. Right? A and D are rational functions. Now, how do I identify whether a function is rational or not? So to identify a function is rational or not, I'm writing this. If y is equals to fx. Basically, I'll not write it as fx. I will write it in its purest form. Purest form mane, how do we define a rational function? Rational function will be something like this. Px upon qx. So if y is equals to px upon qx, if y is a form, I mean, y is this kind of a function, which is known as what? Rational function. Obviously, qx should not be equal to 0. Your denominator to can never be equal to 0. Right? So if y is equals to px upon qx is a rational function, then y is always continuous. Y is always continuous, barring the points. You just have to exclude the points where your denominator is 0. Barring the points, qx is equals to 0. So just leave those points where qx is 0. Other than that, at all points, it will be continuous. You don't need to check. Yes, you were asking something? Yes.
What is the meaning of barring?
Barring mane matlab excluding.
Okay, sir.
I mean, it will be continuous, excluding the points where your denominator is 0. So if somebody asks me fx, I mean, examine the now I'll come again to the question number A or D, both are same now. Okay, these both are rational functions, क्योंकि A वाले में भी आप देख सकते हैं numerator is constant polynomial and denominator is a linear polynomial, while in D numerator is a quadratic polynomial and denominator is a linear polynomial. So A and D both are rational functions first of all, right? So I'll solve one of them, any one of them, and before solving I am telling you the answer. Before solving, first listen to this answer directly. So what I would say is, let's say somebody asks me, examine the continuity of fx is equals to, examine the continuity of fx is equals to 1 upon x minus 3. So I will check whether what kind of a function is it. This is a rational function, right? Now, as soon as I observe this, as soon as I realize that this is a rational function, I would directly say this is continuous everywhere, barring x is equals to 3. So this function right here, A, is not continuous at x is equals to 3. This is the final answer. So can you tell me the answer for D? Is there a point of discontinuity for function? I mean, for part D, do we have a point of discontinuity or not? If yes, then what is that point of discontinuity? Okay, what is point of discontinuity? Where the function is not continuous. Like in question number A.
For D.
Yeah, for D, I'm asking right now. What will be the point of discontinuity? Like for A, the point of discontinuity is x is equals to 3. At x is equals to 3, this function is not continuous.
So x is equal to -5, it will not be.
X is equals to -5, right? जहां पे भी denominator 0 होगा, right? Okay. तो first of all, answer तो मैं ऐसे निकाल सकता हूँ. Austin, did you get it?
Yes.
Okay. So the answer is pretty direct. है ना? We don't need to do much for getting the answer or for getting our understanding right. Okay. But now the question is, okay, यार मेरे को how do I find out for which point I am checking the continuity? So whenever you have these kind of functions, you'll have to check. I mean, in these cases, B and C, you can directly say that the function is modulus or the function is polynomial. So it is continuous everywhere. We don't need to check. I mean, don't write it. We don't need to check. But you can say that by the definition, we can say by the definition, we can observe that the given function is a modulus function or the given function is a polynomial function which is defined everywhere or which is continuous everywhere. Hence, fx is continuous everywhere. You can write this, right? But in these A and D cases, what you will do is you will find out the discontinuity at this point. तुम्हें पता है अभी ये कहाँ पे discontinuous है. You know that this function is not continuous at x is equals to 3, or this D part is not continuous at x is equals to -5, right? So what you will do is you will solve this question for the point of discontinuity only. मतलब जहां पे continuous है वहां पे तो दिखाने का क्या ही point है ना, वहां तो आंसर सेम आना ही है. You just show it at the point of discontinuity. So for example, I'm going to solve D part. So I'm solving D. So to solve D, check, I would write it like this, check fx is equals to x square minus 25 upon x plus 5. X is not equal to -5. Also write this, is continuous at x is equals to -5. तो what I can do is, वैसे तो मुझे इतना करने का जरूरत भी नहीं है, बट चलो मैं थोड़ा और कर लेता हूँ. What I would still like to go very conventionally. So I will first find out LHL at x is equals to 5, or sorry, at x is equals to -5. So this will be limit x tends to -5 negative. See, -5 negative लिखा जा सकता है ना, इसमें कंफ्यूज मत हो ना कि ये तो 2 नेगेटिव आ गए. भाई वो ऊपर नेगेटिव लगाया हुआ है हमने, मतलब इतना 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 बेवकूफ नहीं होना है. Okay, so limit x tends to -5 negative fx, right? In the next step, I can write it as -5 negative माने क्या, -5 minus h, right? Okay, तो यार ये जो fx यहाँ पे लिखा हुआ है, पहली बात तो I can still further solve this fx. This is x square minus 25 upon x plus 5. And I can write it as, okay, so before writing this, I would like to further tell you one more thing. ये भी ये लिखा हुआ है x square minus 25 divided by x plus 5. Can I factorize the numerator part and write it as x minus 5 into x plus 5, a square minus b square?
Yes, sir.
And then I can cancel out x plus 5 from the numerator and denominator. So this function is basically x minus 5, right? Do you agree with this?
Yes, sir.
Okay. So Chavez, can we say that both of these are same? I mean, fx is equal, if I write both of these things, let's say I'm giving this name as gx. If I'm saying fx is equals to x square minus 25 upon x plus 5 and gx is equals to x minus 5 are same or not, what is your answer? What is your opinion on that?
Same.
Same. Okay. Everybody's same? I mean, everybody's opinion is same, or do someone has different opinion? Okay.
So like here we simplified, right?
नहीं यार शायद सेम नहीं होंगे. मतलब this looks same but these things are not same actually. अच्छा अब ऐसे देख. Okay, नहीं शायद ऐसे ऐसे ऐसे. Okay, this is one way to observe this. कि yeah, these are same. Now, but before that, you need to understand what are same functions. I mean, if you are saying that both of these functions are equal, what does that mean? This does not only mean कि वो function का expression same हो जाए बस. नहीं. If you are saying na that these two functions are equal, then their domain and their range must be same. Along with the expression, their domain and range must be same. Now you consider fx and gx. What is the domain of fx? All real numbers except -5. You can't put -5 there. But consider gx. You can put anything. There is no limitation. तो same तो बिल्कुल नहीं है वो. क्योंकि -5 at x is equals to -5, fx is not defined. While at x is equals to -5, gx has some answer. What is the answer? -10. Did you understand this?
Yes.
कोई बात नहीं, थोड़ा एक बार और टाइम ले सकते हो. You can take your time. But fx and gx both are not same. No, you can define gx at x is equals to -5, but you can't define fx at x is equals to -5. So I'll say one statement now. Okay, listen to it. This is very important how they have written the expression of the function. If they have written x minus 5, this is a different expression. And if they have written x square minus 25 upon x plus 5, this is a different expression. Why? For that y, we are solving this d part. उस y का आंसर के लिए ही हम d part solve कर रहे हैं और कुछ नहीं है बस. ठीक है? Why? क्योंकि gx is continuous at x is equals to 5. Or rather x is equals to -5. Your gx is continuous at x is equals to -5, but your fx is not continuous at x is equals to -5. So when you will draw the graph of these, na, gx and fx, this fx has graph this. I'm just for the better understanding part, you don't need to remember these things. But if you are connecting or if you are connecting with me at some point, so you can understand this, that fx has this graph. Sorry. This is the graph. This is at x is equals to -5. So at x is equals to -5, there is a point of discontinuity. While if you draw gx, it has no point of discontinuity. दोनों straight line ही है. Both of them are straight line, exactly same. But there is a point of discontinuity at x is equals to -5 for fx, while there is no point of discontinuity for gx. That is why they both are different. That is why you are understanding the concept of limits and continuity. Continuity नहीं बताया हमें ये बात, that fx and gx are different. Because fx is not continuous everywhere, while gx is continuous everywhere. So it is very important to understand how the expression is written. अभी मैं solve करने के लिए इसको x minus 5 ही बना दूंगा. Also understand this. I'll make it x minus 5 only for solving this limit. But that does not change the fact that fx is x square minus 25 upon x plus 5. Fx is not x minus 5. But to solve this part, to solve the limits, I will use my factorization technique to find out the answer. मतलब यार 5 पे तो आंसर नहीं है, -5 पे तो इसका आंसर नहीं है ना. Also understand this. See, LHL and RHL at x is equals to -5 exist for fx also and for gx also. fx पे भी LHL RHL exist करेगा -5 पे. There is a definitely there is a finite answer for LHL as well as RHL for fx and for gx also. But fx does not exist at x is equals to -5, while gx exists at x is equals to -5. That is the only difference. Otherwise, LHL and RHL of both the functions will be same at x is equals to -5. So LHL RHL में कोई difference नहीं है. They are same for both the functions, but value of the function at that point is different. I mean, that does not exist for fx, but gx के लिए that exists. Right? So I'm removing this now. This is just for you to understand the basics, what we are talking about. Yeah. So I will write this as x minus 5. I will not write it like, I mean, I can write it in any way I want. But so, okay, so first of all, yeah, I'll make it easy for you. So this is nothing but -5 negative. So this becomes -5 negative whole square -25 divided by -5 negative +5, which can be further solved like limit h tends to 0. This is -5 minus h whole square hota, but I'm just acha, okay. Can I write here only this x -5? That will be a better understanding here. Otherwise, we are just making it tough. So this is similar to x -5. This is x -5 just for your simplification. But we do know that x cannot take value -5 here. So this will be -5 minus h. Instead of x, you can replace with -5 negative, which is nothing but -5 minus h minus 5. So the answer would be, put h is equals to 0, the answer would be -10. Similarly, RHL will also be -10. You can find that out yourself. But you will write, but fx is not defined at x is equals to -5. It implies that RHL will also be this. You can check that out. RHL will be the same. So if this is not defined at x is equals to -5, then we don't have any value for f -5, right? And two things are same, but the third thing is not defined. That is why fx is discontinuous. Fx is discontinuous at x is equals to -5.
Sir,
Yes.
like for RHL and LHL, we can simplify, but for f of x, we cannot simplify.
मतलब RHL में भी देख यही होगा ना, बस सिंपल -5 प्लस h हो जाएगा वहां पे. एक्सप्रेशन तो पूरा सेम ही है और h से तो कोई फर्क ही नहीं पड़ रहा ना, h तो 0 ही है, तो RHL भी -10 ही आएगा. वो तेरे को सॉल्व करना है बट खुद, इसलिए छोड़ा है मैंने. बट ये LHL RHL की वजह से नहीं, ये इसलिए डिसकंटिन्यूअस है क्योंकि we cannot define the value at x is equals to -5. All the three things must be equal, na? LHL, RHL, as well as value of the function at given point. Value of the function at the given point. Oh, sorry, given. There was no given point, but we do know what is the given point in these cases, where your denominator is 0. The first point was this only, that in all the rational functions, your point of discontinuity will not be given. But you do know what is the point of discontinuity. The point of discontinuity is where your denominator is 0. So you will take that point and value of the function is not defined at that point. So you will directly use this. क्योंकि हम तो पहला क्वेश्चन कर रहे हैं, इसीलिए I have solved for LHL and RHL. You don't need to solve for LHL and RHL, by the way. You could have just simply said the value of the function is not defined at x is equals to -5. The function is discontinuous at x is equals to -5. You could have simply said this. हाँ जी, समझ आई बात? Did you understand this? I want to ask to everyone first of all, because we are going to solve one last question today. And we also need half an hour in the next class to solve some good questions for continuity, but the concept is over. Just so you know. There is one more type of question which will be asked in your home exams, so definitely. In your board exams, maybe. If there is a question from continuity in board exam, the question will be that. These are some harder questions. तो questions तो वही होंगे, concept same ही होगा, but हाँ थोड़े questions के तरीके अलग होंगे solve करने के. I mean तरीके नहीं, थोड़ा calculation बढ़ जाएगी. But yeah, the concepts will be same only. So you'll need half an hour in the next class also. But before that, we do have 10 minutes now. So please feel free to ask me if you have any doubt regarding the concept of how to find out the continuity.
So,
Yes.
so like for RHL and LHL, we can use this x minus 5. So why can't we use it for f of x?
So we can say no. We can't use that for fx is equals to, at x is equals to -5. See, what does that mean if LHL and RHL are equal? Let's say if LHL and RHL both have some value. If the value is different, yeah, please, puch. Okay, तो पहले मेरी बात सुन ले फिर एक बार कि if the value is different, see, if LHL and RHL both have some finite value, but the value is different. Let's say LHL is -5 and RHL is 0. So what I would say is that limit does not exist at this point if LHL and RHL is not same. Now let's say second case, if LHL and RHL both are finite and both are equal also. So I would say that the limit exists at this point. Limit exist माने कि उस पॉइंट से थोड़ा इधर और उधर दोनों पे बराबर ही वैल्यू है, तो लिमिट एग्जिस्ट तो कर रही है ना। अब इसके बाद मैं थर्ड स्टेप पे जाऊंगा, विच इज टू फाइंड आउट द वैल्यू ऑफ द फंक्शन एट अ गिवन पॉइंट। तो इफ LHL एंड RHL बोथ आर इक्वल, तो बस उसका मतलब ये होगा कि हम ये बोल सकते हैं हाँ लिमिट एग्जिस्ट करती है इस पॉइंट पे, नथिंग एल्स। वी कांट से दैट द फंक्शन इज कंटिन्यूअस। आप पूछ। मतलब ये चीज हमें उसका ग्राफ बनाने में हेल्प करेगी शायद। ये भी बता देता हूँ कि इसका यूज केस क्या है, इसका एप्लीकेशन क्या है। वी विल यूज दिस इन ड्रॉइंग द ग्राफ। अभी पूछ सकता है, कोई भी प्रॉब्लम है तो। ओके, ठीक है, चलो नाउ लेट्स सॉल्व वन मोर क्वेश्चन। We have not discussed this kind of function in functions. मेरे को काफी पसंद भी है यार ये फंक्शन, ऐसे मतलब अच्छा सा लगता है थोड़ा। क्या आप जानते हैं इस फंक्शन के बारे में? टू सम ऑफ या सम ऑफ समवन, एनीवन नो अबाउट दिस फंक्शन? Okay, so this is known as GIF.
It is a greater integer function.
Yes, greatest integer function. So what does it do? Chavez, बता दे. Like the job of modulus function is to make everything positive. What is the job of greatest integer function?
To make integer.
To make everything integer. Whatever input you give this function, greatest integer function, its output will always be an integer. That is why the name is greatest integer function, right? So iska kaam to is the job of GIF is to produce an integer. Now how the integer will be produced? Let's understand the functioning. So okay, so let's say I am giving these are curly brackets, by the way, curly braces. Okay, so let's say I'm giving this I'm giving an integer as the input. I want to find out the GIF value of 3. I can call it as GIF 3. GIF of 3. So GIF of 3 will be 3 only. Why? Yeah, the job of GIF is to produce an integer. If there is, I mean, if you're giving an integer as an input, so its job is already done. It has nothing to do, right? The job of GIF is to produce an integer output, an integral output. Now, if you are giving already an integral input, then it has nothing to do with that. It will simply replicate, it will simply repeat your input as the output. तो आपने जो इनपुट दिया वो ये बाहर दे देगा अगर वो इंटीजर इनपुट दिया गया है. Understood? Easy. Now the problem arises when there is not an integral input. So for, let's say I am giving it as 1.4. What will be the answer of curly braces 1.4? The answer will be 1. जो just छोटा integer है. The integer, I mean the greatest integer that is just smaller than 1.4 will be the answer. So 1.4, GIF of 1.4 will be 1. GIF of 2.2 will be what? 2. No. Just छोटा integer answer होगा. So the integer that is just smaller than the value, if the value is not integral, if the value is in decimal, then the integer just smaller that, I mean, so, if I'm using 2.2, then the integer just smaller than 2.2 will be your answer. Integer just smaller than 2.2 is 2. 1 is also a smaller, 1 is also a smaller integer than 2.2. But we are not talking about बहुत सारे smaller होंगे यार ऐसे तो. We are talking about the just smaller integer. Okay. So the GIF of 2.2 will be 2. So can you tell me the GIF of 2.6? Madhya, can you tell me what is the answer of GIF of 2.6?
Three.
Why 3? Is 3 smaller than 2.6? 3 is bigger than 2.6, no? So answer हमारा होगा 2.6. If I am talking about GIF of 2.6, then the answer will be this integer just smaller than 2.6, which is
Sorry. Right.
it will be 2 in this case, right?
Yeah.
Okay, so can you tell me the answer for this? 0.45. GIF of 0.45.
0.
0. Austin, what will be the answer for this? 1.45.
1.
1. Correct. Now tell me the answer for this. Minus 1.45. Okay, before you give me an answer, I would like to suggest a fact. 98% student solve this incorrectly. Now think about it and answer me.
-2.
-2. Correct. Correct, Madhya. Good. See, we have to find out the smaller one. Okay. तो देखो जब हम पॉजिटिव वाली साइड पे होते हैं तो स्मॉलर पता होता है. 2.6 का 2 है, 1.4 का 1 है, 2.2 का 2 है. बट -1.45 का -1 स्मॉलर इंटीजर नहीं है. -1 is a bigger integer than -1.45. The answer will be -2. So on the negative side, just be careful. But concept वही है. Just छोटा जो integer होगा वो इसका आंसर है. ठीक है जी? That is how we solve it. Okay? ये इसका कॉन्सेप्ट है. ये छोटा सा GIF ये करता है. GIF का काम है इंटीग्रल वैल्यू प्रोड्यूस करना. GIF, the job of GIF is to give an integral output. If you are giving it an integer as an input, it will just replicate your input. If you are giving it a decimal number, then it will provide the just smaller integer of that decimal as your output. Okay. Now we have to check whether this function is continuous at integers or not. Okay, chalo, let's make it easy. So other than integers, I am giving you a point at x is equals to 2. We need to check it for x is equals to 2. Okay, chalo, let's solve it. Solve it with me. Okay. So I am first finding out LHL at x is equals to 2. So this will be limit x tends to 2 negative, right? fx, right? In the next step, I can write what? Limit h tends to 0. And instead of x, I can use 2 negative. What is 2 negative? 2 minus h, right? Okay. Limit h tends to 0. What is 2 minus f2 minus h? Will be gif of 2 minus h. अब भाई सीधा h को पुट मत कर दे 0. रुक जा रुक जा रुक जा रुक जा, थोड़ा समझ ले. फंक्शन का काम है कुछ, है ना? बेवकूफ तो है नहीं, फंक्शन हमने बनाए हैं इतने सारे, मतलब जिसने भी बनाए हैं उसने भी कुछ सोच समझ के ही बनाए होंगे. ऑस्टिन लीव दिस, आई एम जस्ट ऐसे ही बकवास कर रहा हूँ. Okay, so limit h tends to 0. We are solving out GIF of 2 minus h. So don't put h as 0 directly. If you put h as 0, the answer will be 2. Right? You put h 0, then 2 minus 0 will be 2, and greatest integer function of 2 will be 2. That is the most common mistake everybody does here. Think about it. हम जानते हैं, we know that h is tending to 0, but we do know that h is not exactly equal to 0. So when I say 2 minus h, what do I mean? 1.999999999, right? We have talked about it.
One.
When we were understanding the concept of left hand limit and right hand limit, we have talked about it. That 2 negative money, the value just smaller than 2. Obviously, this is not equal to 2. मतलब एकदम पास में ही है 2 के. This is approximately equal to 2, but not exactly equal to 2. And that makes the whole difference here. Why? Because if this value is 1.999999, then the answer is 1. Because this is greatest integer function. 1.99 also has answer 1. 2 has answer 2. 2.01 has answer 2. 2.5 has answer 2. 2.67, 2. But if I'm calculating the greatest integer function for 1.99, then the answer is 1. Did you understand this? What did we just do?
Yes, sir.
Austin?
Yes.
Mahmuddin? Madhya?
Yes.
Yes, sir.
And Tharif and Shahid? See, we have not directly given the value of h as 0. Instead of, if we are using 0, then the answer will be 2. But we have to go through the concept. What is the concept of greatest integer function? Greatest integer function says, please focus on the value inside. The value inside is 1.999999. Not कहीं और होते तो फर्क नहीं पड़ता यार इस बात से, बट यहाँ पे फर्क पड़ रहा है क्योंकि आंसर 1 हो जाएगा. आपने अभी ऊपर जगह जाके h को सीधा सीधा 0 रखा. हाँ रखा क्योंकि फर्क नहीं पड़ रहा था भाई उधर. There was no difference it was creating at that point. But at this point, the whole difference is about this. If you put h as 0 directly, then the answer will be 2, which will be in the RHL case. If you find out RHL at x is equals to 2, then you are basically finding out limit x tends to 2 positive fx. This is limit h tends to 0, f of 2 plus h, right? Now, if you put h 0, तो कोई difference नहीं होगा. There is no difference that h is equals to 0 is going to make here. Why? Because this is 2 plus h. 2 plus h माने this is representing a value just greater than 2. Okay, the answer will be 2 only. If you put h को 0 directly put कर दो या ऐसे concept से समझ लो, दोनों ही केस में आंसर 2 ही आएगा. But आपको जाना conceptually है. You have to go through concept. Here 2 plus h is representing a value just greater than 2. And the GIF of a value just greater than 2 is 2. Right? Oh, so this is your first equation. This is your second equation. Now we need to solve third part, which is find the value at 2, f2, which is greatest integer function of 2. The answer is 2. But you can observe from first, second, and third, greatest integer of function of x is discontinuous at x is equals to 2. In fact, greatest integer function is discontinuous at every integral point. Why? Now you have only considered 2. Now let's consider 0. 0 पे आंसर क्या होगा? 0. 0.1 पे 0. 0.2 0. 0.9 0. 0.99 0. At 1, the answer will be 1. So the graph of greatest integer function is like this. This is also known as stepwise function, by the way, because the graph is like in the shape of steps. This is y is equals to greatest integer function of x. Discontinuous at all integers. Because at 1.99, the value will be 1. At 2, the value will be 2. Similarly, at 2.99, the value will be 2. But at 3, the value will be 3. Okay, so this was the last question of today's class. We need to solve 2-3 more questions to get over the continuity, and we will do that in the next class.